Okay, till now we have discussed about LPP. In LPP we have seen graphical method and algebraic method. Two methods till now we have seen. Today we will discuss about the simplex algorithm or simplex method, or I can say method which is much popular than the other method to solve any LPP, right? And simplex method is generally used to solve the LPP. Any type of LPP, any type of variables LPP can be solved with the help of simplex algorithm, right? Just like graphical method has some limitation, only the two variable problem can be solved. Algebraic method can be solved more than two variable problem, but it takes a lot of time, a lot of complexity in the methods, that's why not much popular. And simplex method also can solve a problem, either any type of problem, either of two variable or more than two variables. So before starting simplex method, we have to understand the algebraic form of simplex method. Okay, how algebraically before arriving to the, or you can say before understanding the tabular form of simplex method, how actually the simplex method work in the tabular form, right? So we have to understand the algebraic form of this simplex algorithm, right? So I am considering the same example last day I have considered for the graphical method as well as for algebraic method. Same example I am considering to understand the concept of simplex algorithm, right? So a method better than the algebraic, it does not evaluate a feasible solution. Always we start the quality of the simplex method. We start a problem always from initial basic feasible solution, and further towards the improvement of that particular basic feasible solution. So there is no infeasible region, just like in algebraic method. We initiate problem, first we get the basic feasible solution, then we move towards the optimality. Second, in the iteration, because it is iteration process, so in each and every iteration we are getting a value better than the previous value. Simplex method guarantees that the value obtained is always better than the previous value, and it also has a termination criteria. The moment it found the optimum value, it terminates. So the same example last day I have considered, in last video I have considered the objective function of maximization type and the constraint of less than type, and it is the non-negativity restriction. And now today we are interested to solve this problem with the help of simplex method, right? So how we can solve with the help of simplex method? Firstly, we have to convert inequalities into the equalities. Means whatever the equalities are there, we have to convert into the form of equations, means equalities. How we can convert? By adding slack and surplus variable. If the constraint of less than type, then we have to add slack variable. If the constraint of greater than type, then we have to add surplus variable, right? And second important thing is also there, because this problem belongs to the less than or constraint are less than type, so we have to add slack variable, and this slack variable does not has any contribution in the objective function, means they will not affect the maximization of the profit. So whenever we write with the objective function, the slack variables come with the zero coefficient, right? And second term, before starting the simplex problem, it is also consider if the right hand side of the problem, if the right hand side of the equalities is negative, then we have to make positive. Negative in the right hand side means that showing the infeasibility of the solution. And before starting the problem, the solution must be the basic feasible solution. That's why in the right hand side of the constant is always a positive value. If there is a negative value, then we have to multiply by -1 in both the side, so that in the right hand side we start with positive value, right? So in this problem, to obtain the first basic solution, we can fix x1 and x2 to the non-basic variable, means fixed to the 0 value. Whenever the variable is fixing to the 0, that variable is called non-basic variable, and other variable are called basic variable. So these are the basic variable and these are the non-basic variables. So we can start problem here. So here we can convert the equation, the objective function of maximization type, that is 6x1 plus 5x2, because there are two select variable s1 and s2, and they are not contributing in the objective function, but we have to show in the objective function because the number of variable become 4 now. So 0 is there, and the coefficient of 0 representing this slack variable does not have any impact on the objective function. The value of objective function is same, remains 6x1 plus 5x2. And these are the, because the constraint of less than and equal to type, that's why we are adding select variable. This constraint is also less than and equal to type, that's why we are adding select variable as 2. Now the number of variables are moved towards 4. Number of variables is 4, right? And again in the last day in algebraic method we have also mentioned that if there are number of variable is 4 here, n is representing number of variable, m is representing number of equation, so n minus m is representing, that is 2, 4 minus 2 is equal to 2 non-basic variable, and number of equations represents, m represents basic variables, so m is also is 2 here. So in this problem 2 basic variables and 2 non-basic variables, right? And to find out the initial basic feasible solution, we have to keep 0 as a non-basic variable. Just like to find out the initial basic feasible solution, we are assuming 2 non-basic variable, and I am assuming x1 is equal to 0 and x2 is equal to 0. If I put x1 and x2 is equal to 0, the solution of the problem become s1 is equal to 5, s2 is equal to 12, and the value of z become 0. That is the initial basic feasible solution. That is initial basic feasible solution. Right, the quality of the simplex method, we always start a problem with initial basic feasible solution. Once we get the initial basic feasible solution, then we move towards the optimality, right? So that is the initial basic feasible solution. After getting the initial basic feasible solution, before starting the tabular form, I would like to discuss something, how in tabular form, how we are solving the simplex method with the algebraic way. How actually it is multiplying, dividing, actually choosing minimum and maximum, how it is possible. That is understand with the help of algebraic terminology, just like this. Now the equation is that simple, we have write iteration number 1, and iteration 1 write basic variable and objective function in the terms of non-basic variable. We have decided here x1 and x2 are 0, and these are non-basic variable. And what are the basic variable? S1 and S2 are the basic variable. So in iteration 1, because it is the initial basic feasible solution, and we get the value of 5 and 12 and z is equal to 0, right? So we have to, in iteration first, we have to write basic variable in terms of non-basic variable, right? From last we can see here, if I write s1 here, so s1 is equal to 5 minus x1 minus x2. If I write s2 here, so s2 is equal to 12 minus 3x1 minus x2, right? And if I put s1 s2 in this equation, it does not have any impact, so objective function remains same, z is equal to 6x1 plus 5x2. That is the iteration number 1, or I can say equation number 1, equation number 2, equation number 3. I hope there is no doubt about it. Now, if I kept x1 is equal to 0, x2 is equal to also 0, s1 become 5, s1 become 5. If I kept in the second equation x1 is equal to 0, x2 is equal to 0, s2 become 12. If I put x1, x2, 0 here in the objective function, z become 0. So that is the initial basic feasible solution. The first criteria to solve any simplex method, we have to find initial basic feasible solution. So that For in further iteration we can improve that value. Here the z value is 0. The main motive of the simplex method, we are in feasible region. Now we have to move towards the optimality. If the solution is not feasible, so it is very difficult to move in the direction of optimality. That's why we are starting problem with the basic feasible solution, right? So for the next iteration, for the next iteration we have to choose another combination of decision variables, or we can say which value we have to increase. How we will decide? That is decided on the basis of contribution in the objective function. Just like the contribution in the objective function, x1 has the more contribution because the coefficient of x is 6 and coefficient of x2 is 5. Out of x1, x2, which has more contribution in the objective function? Coefficient of x1. It means we have to increase x1. And how much we can increase? How much we can increase? Just a second, we can show how much we can increase. We have to decide on that basis. Just like this. Means the purpose is that we are interested which variable will enter and which variable will leave. Means any value of x1, so that either s1 is equal to 0 or s2 is equal to 0. Because if any of the s1, s2 is equal to 0, that become non-basic variable and x1 will become basic variable. The meaning, then in the next iteration we will do, what we'll do? We have to choose x1 in such a way so that any of s1, s2 will move from here. Means become non-basic variable. Means the value become 0. So that x1 can enter. Right? So try to understand it. If I put here 5, x1 is equal to 5. So this s1 becomes 0. If I am putting x1 is equal to 5. If I am in second equation, if I am putting x1 is equal to 4, 3 into 4, 12, 12 minus 12 becomes 0. x2 become 4, x1 is equal to 4, so s2 becomes 0. Now I have two choice, either I can select 4 or 5. Out of 2, one value I have to select so that x1 become basic variable and either s1 or s2 become non-basic variable. Non-basic variable means we are fixing to the 0, right? So suppose if I am taking 4, always taken minimum of 2, always taken minimum of 2, minimum value, always choose minimum value. Why I am saying minimum value? Suppose I am taking 5, suppose I am taking large value. If I keep 5 in this equation, 12 minus 3 into 5, so the value of s2 become negative. As soon as the value s2 become negative, that violates the non-negativity restriction. Non-negativity restriction says all variable must be greater than or equal to 0. If any of the constraint or any of the non-negativity restriction is violates, that will not be the solution of the problem. So that's why always choose minimum value. If we have an option, always choose a minimum value. So in next iteration, if I am choosing 4, s2 becomes 0. So in next iteration, s2 becomes 0, right? And x2 is already 0. New basic variable become x1 and s1. So in next iteration, I will write these equation in terms of I will write x1 in terms of s1 s2 x1 and s1 in terms of x1 s2 s2, right? So in next iteration, okay, all these terminology I have discussed. So that is the equation x1, because x1 become now x1 and s1 are the basic variable and non-basic variable become x2 and s2. Non-basic means we have to fix 0 value here, right? We have decided, we have chosen which value x1 is increases and x1 is taken as 4. Now we have to write these. This is the algebraic form basically, Before moving towards the tabular form, in tabular form there is a set of process, there is a set of steps we have to follow to find out the optimal solution. And how this optimal solution is coming? What is the algebraic behind this tabular form? In tabular form, why we are choosing minimum, maximum key elements of the column and row? How it is taken place? We can have an idea with the help of this algebraic terminology, right? So we have calculated, we have write the equation just like the equation 3x1 12, this x1 equation, that is the equation number 4, and this is s1 equation. In s1 equation we put x1 here, right? If I take the equation from last, here you can see the equation of s1 is 5 minus x1 minus x2, right? And I have taken the x1 equation here. How can I write the s1 equation? 3x1 is equal to 12 minus x2 minus s2, and I put the x1 equation, then x1 value put into the s1 equation, because all terms in the terms of s2 and x2. In this equation, because we are calculating basic variable, so if this side there should be basic variable, and in the right hand side whole variable must be non-basic variable. That's why I put x1 value in this equation as well as in the z equation. In the last one, z equation is 6x1 plus 5x2. So in place of x1 I put this value, so that entire left hand side represents basic variable, entire right hand side represent non-basic variable, so that I am easily able to calculate the value of basic variables. Now if I put non-basic variable 0 in equation 4 and equation 5 and equation 6, if I am putting all these value, so what will I get? If I put s2 is equal to 0, s2 is equal to 0, I will get x1 is equal to 4, s1 is equal to 5, and z is equal to 24. That is the first basic feasible solution, or you can say second basic feasible solution. Prior this, the solution was initial basic feasible solution. After iteration 1 we got the basic feasible solution. After iteration this, we are getting another solution. That solution is the better than the prior solution. And the algebraic behind it, how we are converting these things into a tabular form and following a particular steps of set, how it is possible with the help of these algebraic terminology, right? After that, now the equation is in these terms. Now it is the second basic feasible solution we have obtained here. Initial is called as the first basic and it is called second basic feasible solution. Now another interesting thing, we have chosen x1 already. Now in this we have to decide how much the x2 is increases. Only the x1 we have chosen in the last iteration. Now there is a chance of x2. How much value of x2 is taken so that x2 become basic variable and any of the s1 and x1 become non-basic variable. We have to decide here, just like the previous iteration. Okay, so if I put x2, if I am taking x2 in this equation, if I take x2 is equal to, here I can say, suppose if I want x1 become 0, so what is the value of x2? I have to put x2 is equal to 6. If I put x2 is equal to 6, so that x1 becomes 0. In this equation, in the equation number 5, if I put x2 is equal to 3, if I put x2 is equal to 3, so the s1 becomes 0, so the x1 becomes 0. Now I have a choice between 6 and 3, and we have to choose. In the last iteration I have already mentioned, we have to choose minimum value. Out of 2, minimum is 3. Out of 2, minimum is 3. Right? So we have to choose 3. When we are choosing 3 value, this s1 becomes 0, and when this s1 becomes 0, it becomes non-basic variable. Right? So in next iteration, the non-basic variable become S1 and S2, and basic variable become X2 and X1. So we have to write these equation in terms of X2. So from first equation, the first inequality is given. With the help of that, we have to write X2. Then value of X2, whatever the value of X2, we have to put in this equation as well as in this equation, right? Just like the previous iteration. So we have taken, this is the X2 value, right? From the previous one, we have taken the X2, right? So X2 will become, this equation become X2, that is the equation number 7, right? That is the equation number 7. Again, I have put the X2 value into the X1 value, just like this. If I put X2 here in this equation, in Z also I have to put X2. So I have put the value of X2 in this equation. I am getting this equation number 8. And again, in the Z value, I am putting the value of X2. I am getting Z again. Right now from equation 7, 8, 9, we can get, we having the S1 is equal to 0, S2 is equal to 0, because we have fixed non-basic variable. If I put, so entire left hand side must be in the form of basic variable, and all right hand side must be in the terms of non-basic variable, just like the last iteration I have already mentioned, right? So we have to, if I am putting S1, S2, 0 in these equations, I will get X1 is equal to 4, X1 is equal to 4 and X2 is equal to 3. Sorry, X1 is equal to 2, I will get, and X2 is equal to 3. If I put S1, S2 is equal to 0, S1 is equal to 0 and Z is equal to 27. And now we can see there is no scope of any value to be increased, means we have reached to the termination. Now there is no value to increase, we have already chosen S1, S2 is equal to 0, right? All variable has been considered as a basic variable now. So it is the solution of the problem. So the solution of the problem, X1 is equal to 2 and X2 is equal to 3 and Z is equal to 27. We have solved this problem by graphical method, by algebraic method, by simplex method as well as. The solution remains same in all the cases. In algebraic method, we have done a lot of exercise. The problem become complex because we have already calculated the number of iteration, means the number of possible solutions. Either the value is feasible or non-feasible, we have calculated for both. That's why that method is not much popular, right? That is the basic algebraic behind the simplex method. But every time we will not do this algebraic way. We have to convert into the tabular form and we make some steps. We make some steps, and every time we have to follow that steps to get the optimal value. But before reaching to the tabular form, it is very important to understand how this tabular form is working. So we can understand by this algebraic way. Now if I am converting this into the tabular form, so simplex method can also be solved with the help of tabular form, can also be algebraic form, but algebraic form become complex when the number of variable problem increases. Number of variable is increases. So that's why it is favorable to solve with the help of tabular form. How we can write tabular form? Tabular form always start from initial basic feasible solution. So the problem with us is, this problem is x1 plus x2 less than equal to 5, and we will write x1 plus x2 plus s1 is equal to 5, and second equation is 3x1 plus 2x2 plus s2 is equal to 12, and the objective function is 6x1 plus 5x2 plus 0 S1 plus 0 S2. And non-negativity restriction S1, S2, X1, X2 all are greater than equal to 0. Right, we have this equation. Initial basic feasible solution, we have taken X1 is equal to 0 is equal to X2 and S1 is equal to 5, S2 is equal to 12 and Z is equal to 0. That is the initial basic feasible solution. Tabular form is always start from initial basic feasible solution, and the initial basic feasible solution is what? These are the non-basic variable. Then those variable are fixing to the 0 is called non-basic, and these are called basic variable. And the solution is, because we are calculating with the help of basic variable, so the solution is basic solution, initial basic solution, right? So here we have to write the basic variables column wise and the basic variables, and this table is generally for the initial basic feasible solution. This table is representing the initial basic feasible solution, because in simplex method problem always start from initial basic feasible solution. In further iteration we have to improve the value, means we have to move towards the optimality. Okay, so basic variable, we have writing basic variable is here, generally represented EI, right? And these are the coefficient of basic variable. Coefficient of basic variable in objective function. Coefficient of basic variable in objective function. S1 coefficient is 0, S2 coefficient is 0, we have taken 0, 0. And these are the total variables in the constraint, variables in the constraint. X1, X2, S1, S2, and right hand side represent the right hand side of the constraint. So for first constraint, coefficient of X1 is 1, coefficient of X2 is 1, so 1, 1, coefficient of S1 is 1, there is no S2, so the 0, and the right hand side is 5, so we have write 5. In second equation, second constraint, coefficient of X1 is 3, coefficient of X2 is 2, coefficient of S1, there is no coefficient of S1, so that's why 0, coefficient of S2 is 1, and the right hand side is 12, right? And this Cj is representing coefficient of objective function. Coefficient of objective function 6 for X1, 5 for X2, 0 for S1, 0 for S2. So this way we can draw the table. Table in the simplex method is always drawn from initial basic feasible solution. So we have represented initial basic feasible solution in the form of tabular. Now it is the initial basic feasible solution, we have to move towards the optimality. In further iteration we will move towards the optimality, and how we can move, how we decided. So now we can concentrate on it easily. We can just like this, we can start again. So firstly we have to calculate the value of Zj. Okay, now we have to calculate the value of Zj. What is the Zj? Zj is nothing else, that is the algebraic sum of Ei into Aij. And what is Aij? This is Ei, this is basically representing Ei, and this is representing basically Aij, just like A11, A12, A13, just like this. So it is representing like this. So what is Zj? Algebraic sum of multiplication of Ei into Zj. Just like if I am interested to calculate 1 into 0 plus 0 into 3 becomes 0. 1 into 0 plus 2 into 0 becomes 0. The value of Zj, objective function value. 1 into 0 plus 0 into 0 becomes 0. 0 into 0, 1. So all coefficient of basic variable is 0. All Ei is 0. Right? All Ei is 0. So you can say the Ei is like this. This is the Ei, basically coefficient of basic variables. All Ei are 0. If all Ei are 0, then multiplication become all 0. So that's why for the initial solution become 0. After that we have to calculate Cj minus Zj. On the basis of Cj minus Zj, 6 minus 0 6, 5 minus 0 5, 0 minus 0 0, 0 minus 0 0. Now on the basis of this row Cj minus Zj, we have to decide which variable will enter and which variable will leave from the basic variable table. How we will decide? We have to see if the problem belongs to the maximization, because this problem belongs to the maximization. We have to choose the maximum value of Cj minus Zj. We have to choose maximum value of Cj minus Zj row. Right? So we have chosen this value, just like this. We have chosen this value because it is the maximum value. So it is represented as a key column. Key column. The meaning of key column means means x1 will leave from here. X1 will enter. Key column is representing the entering variable in the next iteration. X1 will be the entering variable in the basic variable table, means this side. So the meaning of key column is that key column decide which variable will leave the basic variable in non-basic variable table and move to the basic variable table. So now we have to decide, okay, if x1 will entering, which variable will leaving? Out of s1 s2, which one is leaving? How it is decided? It is decided on the basis of theta. And what is theta? Theta is nothing else, that is the ratio of right hand side to the coefficient of key column element. Right? So right hand side is 5 divided by what is the key column? This is the key column. We have decided this is the key column. 1, so 5 upon 1 become 5. 12 upon the coefficient is 3 become 4. And this theta will decide which variable will leave from here, either s1 or s2. How? On the basis of minimum value of theta. So out of 2 the minimum value is 4. It means it is the leaving variable. This is known as the key row. On the basis of key row, we have decided the leaving variable. So the leaving, it means the entering variable is x1, means in the next iteration x1 will enter here and s2 will leave from there. Right? And element which is at the intersection of key column and key row is known as pivot element. So this element is known as, or you can say this element is known as the element which is at the intersection of key column and key row. Which element at the intersection point of both column and row? This 3. This element is known as pivot element. Right? The meaning of pivot element, in next iteration this element must be 1. We have to make this element 1, and either below or up element must be 0 by applying the matrix operation. In next iteration, why we are choosing this pivot element? So that in next iteration pivot element become 1. We have to make pivot element 1, and the element which are above or below this element, or we can say in this row element other than this, must be 0. The element in the key column other than the pivot element must be 0. So there is only one element in this column other than this, there is 1. So we have to make this 1 into the 1 to 0 in the next iteration by applying the matrix operation. I hope it is clear. Everything is clear. We have checked how we can calculate the Zj in each iteration, how we can calculate Cj minus Zj. On the basis of Cj minus Zj, we are deciding the leaving variable. On the basis of maximum, if the problem belongs to the maximization, so on the basis of maximum value of Cj minus Zj is decided the entering variable into the basic variable table from non-basic, because this time these are the non-basic variables. Other than these variables are the non-basic variables. Only the two variables at this solution, only the two variables s1, x2 are the basic variable, others are non-basic. So which non-basic variable will enter? It is decided on the basis of the maximum value of Cj minus Zj. And which variable will enter? We have decided here. And which one is leaving from the basic variable table to move the non-basic table? And it is decided on the minimum value of theta. And what is theta? It is the ratio of right hand side to the coefficient of element of key column. So here we have decided, that's why I am representing arrow in that direction, because it is leaving. I am representing arrow in that direction because it is entering. And then we have to choose the intersection of both the column and row, key column and key row. Whatever the element at the intersection, that will represent the pivot element. And for in next iteration, pivot element must be 1, and other than pivot element in that key column, all element must be 0 by applying the matrix operation. So this is the previous one. So in next iteration, we have to make this 3:1. And how we can make this 3:1? Just we have to divide. Suppose this is row number 1 and this is row number 2. So R2 divided by 3. If we are dividing this equation by 3, it become 1. So if I divided by 3, that become 1. 2 by 3 become 2 by 3. 0 by 3 become 0. 1 by 3 become 1 by 3. 12 by 3 become 4. So this way we can make. Right, and this x1 is entering, right, x1 is entering, s2 is leaving. ये leave कर रहा है और x1 आपका enter कर रहा है, and the coefficient of x1 in the objective function is 6. That's why we have write 6 here, because this is representing coefficient of basic variable in the objective function. Now the pivot element become 1. Now we have to make this element is 0. Other than in the key column, other than the pivot element, all element must be 0. So how we can make this element 0? Just by applying the operation. Suppose this is R1, R1 minus R2. R1 is chosen from here and R2 is chosen from here. R1 is this and R2 is this, right? So or directly I can write just like here, it is equal to 1, just like I can write with the help of pencil, so that to make the calculation easy. Always apply matrix operation other than the pivot element row, always, because matrix operation has some property. If you divide from something and you are taken in the starting, then you have to multiply with it. If you applying this operation from R2, then you have to multiply by 3, because you have already divided by 3. That's why whenever you are applying matrix operation, always apply operation from other than the pivot element row. Just like here, the pivot element row is here. This is the pivot element row, R2. I will not apply from R2 minus R1. I am not writing here. I am writing R1 minus R2. Always apply operation on the pivot element row, not by the pivot element row, because it is the matrix operation, it is the matrix property. If I apply from R2, then I have to multiply by 3 R2 minus R1 like this, because I have already divided R2 by 3. So to avoid this confusion, always apply operations from a row which is other than the pivot element row. That's why I am applying R1 minus R2. So because here the 1, here is the 1, I am taking the first equation is this and second equation is this. So I am writing this equation here, 1, 2 by 3, 0, 1 by 3 and by 3 become 4 and by this is become 4. So I directly multiply, 1 minus 1 becomes 0, 1 minus 2 by 3 become 1 by 3, 1 minus 0 become 1, 0 minus 0 become 0 minus 1 by 3 become minus 1 by 3, 5 minus 4 become 1. So this way I can apply the operation, right? So that easily I am able to calculate without any confusion, because there are so many possibilities the question become wrong with the help of only the calculation. You are conceptually correct, but there is a possibility the question become wrong on the basis of the calculation. So that's why to make the simple calculation, just write here with the help of pencil this row, make here with the help of pencil and just apply the operation, and after that you can rough it, right? So in the second iteration you can perform another way, just like I am saying. Okay, so again we have to apply the same procedure, we have to follow the same procedure. So here now we have to calculate again Zj. How we will calculating? 0 plus 6, 1 by 3 into 2 by 3 become 4, and this is again 0, this is 2, and this Z become 6 into 4, 24. So these are the Zj. How we are writing Zj? Zj is, I am writing algebraic sum of Ei into Aij. Just like this is the Ei and these terms are Aij. So 0 into 0 plus 6 into 1, 6. 0 into 1 by 3 plus 6 into 2 by 3 become 4. 0 into 1 plus 6 into 0 becomes 0. Just like this I am calculating. And again Cj minus Zj. Cj is here, 6 minus 6 becomes 0, 5 minus 4 become 1, 0 minus 0 becomes 0, 0 minus 2 become minus 2. So now again we have to choose which variable is entering and which is leaving. So we have to decide on the basis of maximum value of Cj minus Zj, because the problem belongs to the maximization. If the problem belongs to the maximization, in every iteration we have to find which variable is leaving, which variable is entering, on the basis which variable is entering on the basis of Cj minus Zj, maximum value of Cj minus Zj. And what is the maximum value of Cj minus Zj? That is 1. So that become key column. It means x2 will be the entering variable in the next iteration. And now you have to decide which variable is leaving, either s1 or x1. It is decided on the basis of theta, minimum value of theta. And how we are calculating minimum value of theta? On the basis of right hand side divided by the coefficient, that is 1 by 3, that become 3, 4 divided by 2 by 3, that become 6. So minimum value is 3, so it is the key row. So it means S1 will leaving and X2 will entering. So we have to, this is the key row and this is the key column, and intersection is this, and this element is known as pivot element. So it means in next iteration, in place of S1, X2 will be there, and this pivot element must be 1, and other than pivot element in this column, all the element must be 0. Means in next iteration we have to apply, we have to perform matrix operation, then that pivot element must be 1 and this element must be 0, right? So in next iteration we can do just like this, we have done already. So this must be 1 and this must be 0. How it will be 1? We have to multiply R1 into 3. If I am multiplying R1 is equal to 3, so this becomes 0 into 1 into 3 into minus 1 into 1 into 3, 3. This equation comes. And we have to make 0, right? We have to make 0 it. So how we can make 0? Just we have to multiply 2 by 3 is there, 3 by 2, right? So that become 1 and we can apply 0. Or we can say, suppose here is the, this equation is R1 and this equation is the R2, right? We obtain here R1 is here. So we can apply R2, that is 3 by 2 R2 minus R1. Just we have to apply the operation and we will get 1 0 minus 2 1 2. And again Zj, we are calculating Zj, that is again 0 into 5 plus 6 into 1 becomes 6. Here 1 into 5 become 5, 3 into 5 15, 15 minus 12, that become 2, that become 3, and that become minus 5 plus 6 become plus k1, and that become Z become 27. And Cj minus Zj, 6 minus 6 0, 5 minus 5 0, 0 minus 3 0 minus 3 minus 3, 0 minus 1 minus 1, and it is 27. Now this Cj minus Zj also indicates the termination. And how we will decide that we have reached to the termination? When all Cj minus Zj value either 0 or negative. if the problem belongs to the maximization, and if all the value of Cj minus Zj rho either 0 or negative, that indicates the termination criteria for the optimization problem belongs to the maximization of type, right? So this is about the simplex method, right? In this lecture we have seen how a algebraic form is converted into the tabular form, and how we can solve a problem with the help of simplex method in the tabular form, iteration by iteration, and we are getting the better value. And in this we are always have the termination is there. How we can say the termination? We have arrived to the termination, we have reached to the termination on the basis of rho on the basis of Cj minus Zj rho. If all the values in Cj minus Zj is either 0 or negative, that is the termination criteria, right? And the optimal solution is representing x2 is equal to 3, and this is the solution of the problem we can write from here, and x1 is equal to 2 and z is equal to 27. This is the optimal solution. And already we have taken same problem for the graphical method, for algebraic method, now for the simplex method, right? So this way we can solve any problem with the help of simplex method into the tabular form, right? So there is a set of process. Firstly we have to find the initial basic feasible solution. That initial basic feasible solution we have to write in the tabular form. In every iteration we are moving towards the optimality. So this way, by applying the matrix operation, we can obtain the optimal solution. Thank you.